expanded asteroid tracking system can monitor the entire sky. We're talking about monitoring celestial bodies inbound to Earth, asteroids, comets, meteors. University of Hawaii at Manoa, phys.org explains, a state-of-the-art asteroid alert system operated by University of Hawaii Institute for Astronomy, IFA, can now scan the entire dark sky every 24 hours for dangerous bodies that could plummet towards Earth. The NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS for short, has expanded its research to the Southern Hemisphere from 2 existing North Hemisphere telescopes on Haleakala and Mauna Loa. Construction is now complete and operations are underway on 2 additional telescopes in South Africa and Chile. An asteroid that hits the Earth can come at any time from any direction, so ATLAS is now all the sky all the time. John Tornry, IFA professor and ATLAS principal investigator, says the telescopes are located at Sutherland Observatory Station in South Africa and El Sos Observatory in Chile. These locations were selected not only for their access to the southern part of the sky, but also their time difference from Hawaii. They are able to observe at night when it's daytime in Hawaii. The 4-telescope ATLAS system is now the first survey for hazardous asteroids capable of monitoring the entire dark sky every 24 hours. The modest-sized telescopes can image the chunk of sky 100 times larger than the full moon in a single exposure. And the ATLAS system can provide 1 day's warning for a 20-meter, that's a 60-foot diameter asteroid capable of city-level destruction. Since larger asteroids can be detected further away, ATLAS can provide up to 3 weeks warning for a 100-meter asteroid, that's 300 feet, capable of wide regional devastation. An asteroid that large could produce 10 times the destruction of the recent Hunga Tonga volcanic eruption if it were to strike the Earth. 10 times. The UH developed the first 2 ATLAS telescopes in Hawaii under a 2013 grant from NASA's Near-Earth Objects Observatories program, now part of the Planetary Defense Coordination Office. I support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. The 2 facilities on Haleakala and Mauna Loa became fully operational in 2017. First light and first discovery in Southern Hemisphere. After several years of successful operation in Hawaii, IFA proposed for additional NASA funds to build 2 more telescopes in the Southern Hemisphere. IFA sought partners to host these telescopes and selected the South African Astronomical Observatory, SAAO, in South Africa, and a multi-institutional collaboration in Chile. The ATLAS augments already substantial astronomical capability in both countries. And despite delays due to COVID-19 travel restrictions and supply chain complications, the ATLAS team remotely supervised the assembly of the ATLAS telescopes in coordination with international collaborators in South Africa and Chile. In South Africa, the construction effort was led by SAAO, and in Chile, the team consisted of multiple partners, including the Millennium Institute for Astrophysics and OBSTEC, which operates the private El Sos Observatory. On January 22nd of this year, a few days ago, ATLAS Southern and South Africa discovered its first near-Earth object, NEO 2022 BK. It's a 100-meter asteroid of over 300 feet that currently poses no threat to Earth. To date, the ATLAS system has discovered more than 700 near-Earth asteroids and 66 comets, including detection of 2019 MO and observations of 2018 LA, 2 very small asteroids that actually struck the Earth. The system is especially designed to detect objects that approach very close to Earth, closer than the distance to the Moon, about 240,000 miles or 384,000 kilometers away. The new ATLAS telescopes join existing ground-based surveys as well as other next-generation ground-based NEO detection systems in the works, and according to Larry Deneau, IFA astronomer and ATLAS co-principal investigator, fortunately, NEO hunting is a cooperative global effort, and the enhanced ATLAS complements the existing ground-based NEO search programs, NEO being the Near-Earth Objects search programs, namely UH's own Pan-STARRS and the Catalina Sky Survey in Tucson, Arizona. All these systems have different specialties, and together they're working to keep us safe from hazardous asteroids that could strike anywhere from days to decades in the future. And this was from the University of Hawaii at Mauna Loa on phys.org. And we're going to go see that ATLAS also discovered, first of its kind, asteroid with a comet-like tail. We think of asteroids and comets as distinct types of small bodies, but astronomers discovered an increasing number of crossovers. These objects initially appear to be asteroids and later develop activities such as tails that are typically of comets. Now the University of Hawaii Asteroid Terrestrial Impact Last Alert System, ATLAS for short, has discovered the first known Jupiter Trojan asteroid to have sprouted a comet tail. ATLAS is a NASA-funded project used wide-field telescopes to rapidly scan the sky for asteroids that might pose an impact to Earth, but a threat to Earth, but they're searching most of the sky every 2 nights. ATLAS often finds other kinds of objects that are not dangerous but are very interesting. Now in 2019, the new ATLAS images caught 2019 LD2, now truly looking like a comet with a faint tail made of dust or gas. The asteroid passed behind the Sun and was not observed from the Earth until late 2019 and early 2020. But upon its reappearance in the night sky, April of 2020, routine ATLAS observations confirmed that it still looks like a comet. These observations show that 2019 LD2 has probably been continuously active for almost a year. And while ATLAS discovered more than 40 comets, what makes this object extraordinary is its orbit. The early indication that it was an asteroid near Jupiter's orbit have now been confirmed through precise measurements from many different observations. Trojan asteroids follow the same orbit as a planet, but stay either around 60 degrees or ahead or 60 degrees behind along the orbit. Earth has at least one Trojan asteroid, and Neptune has dozens. Jupiter has hundreds of them. The Jupiter-Trojan asteroids orbit the Sun in 2 huge swarms, one swarm orbiting ahead of the planet, where 2019 LD2 was found, and one swarm orbiting behind the planet. The Trojan asteroids have been captured into these orbits by Jupiter's strong gravity, and what makes 2019 LD2 so interesting is that we think most Jupiter Trojans were captured billions of years ago. Any surface ice could vaporize to spew out gas and dust, should have done so long ago, leaving objects quietly orbiting as asteroids and not behaving like comets. We've believed for decades that Trojan asteroids should have large amounts of ice beneath their surface, but never had any evidence until now. ATLAS has shown that the predictions of their icy nature may well be correct. And what could have made 2019 LTD suddenly show cometary behavior? Maybe Jupiter captured it only recently from a more distant orbit where surface ice could still survive. Maybe it recently surfaced a landslide or an impact from another asteroid, suffered a landslide or an impact from another asteroid, exposing ice that used to be buried under layers of protective rock. New observations to find out are being acquired and evaluated, and what's certain is that the universe is full of surprises, and surveys to guard the Earth from dangerous asteroids often make unexpected discoveries of harmless but fascinating objects that can reveal more about our solar system's history. Even though the ATLAS system is designed to search for dangerous asteroids, ATLAS sees other rare phenomena in our solar system and beyond while scanning the skies. This is what ATLAS project principal investigator Larry Deneau says. He says it's a real bonus for ATLAS to make these kinds of discoveries. This was from University of Hawaii at Manoa. Roy Gal, University of Hawaii, Manoa, unfuse.org. Please leave your comments. Thank you for your support.